I'll give you a quick introduction so you understand where we're coming from. My name is Osherove. I've written a few books in the past. Art of Unit Testing just came out a couple of years ago with 3rd edition. Elastic Leadership, and I work as a chief architect at Verbit AI. Everything in this talk you can see on my blog at robotpaper.ai. Actually, I highly recommend it. I have a blog for every subject that I care about. So there is a blog about unit testing. That's a separate domain. There's a blog about Elastic Leadership, separate domain. There's a blog about Pipeline Driven, which is a book that's not finished yet. And then there's this blog, which is everything about AI. So you can find me all across the web. But unfortunately, nobody reads books anymore. So what is the best benefit to have been having had written a book? The best benefit is that I can go to, let's say, Cursor or any code review tool, and I can give it a prompt that says, I want you to review these tests in the style of Roy Osherove, readable, maintainable, trustworthy. And because, I don't know if legally or illegally, all the AIs have been trained on all our books and all of our blogs, then that content finds its way, and I don't even have to prompt it. What does it mean to have readable, maintainable, trustworthy? And if you're refactoring your legacy code, here's a prompt that will be worth its weight in gold. If you're going to refactor something, tell it to help you refactor or plan the refactoring based on working effectively with legacy code by Michael Feathers. Has anybody here ever read that book? Highly recommended, worth its weight in gold, patterns for refactoring. And the whole point of this talk is that AI is really there to be able to change or enable new ways of working. But we have to come up with new ways of working with AI. We can't just keep the old ways. And one of the ways that AI can actually help is by transforming huge amounts of information into condensed blobs of information and actually use that in the future. Another quick note about AI. Has anyone here ever worked with the Notebook LM? Have you ever tried it? In the latest versions, it's amazing. So what I did is that about 30 or 40% of this talk are slides generated by Notebook LM. What I did is I gave it the blog post that you see here and the source code for RepoSwarm, which you will see. And I said, generate a bunch of slide deck based on it. And I wanted to see how well it's going to do. It did really, really, really well, to the point where I kept probably 60% of what it created, and I reused it in a bunch of different forms in these slides. So if you haven't tried Notebook LM, and if you haven't tried all of the new AI tools, try them. They will find ways to close specific loopholes that you've always wanted to close, to enable you to do things that you've always wanted to do. And RepoSwarm is actually the same thing. So I'll give you some examples of what I have to do as a chief architect, but this will apply to any developer that has to work in any company that has many repositories. So when I joined Verbit, Verbit has about 90 developers across, probably 12 different teams, a lot of legacy code, 400 plus repositories. But my job as a chief architect is to make sure that we are compliant, that everybody lives up to standards, we have security, we have good practices in place, we update technologies, we make sure that cross-system design actually works. When we do migrations or we move to new types of architecture, we want to make sure it actually works. We want to map out our dependencies, we want to document, we want to be able for everybody to be onboarded very easily, and a lot of other things. It's a cool job, I like it. I like thinking at the meta level and then jumping into very low level when it needs to. Problem is that when you have to do that stuff across 400 repositories, nobody can really, realistically do that. So what we have to do is we have to choose the most common things that are the most played out and that everybody touches, and we have to find ways to continuously document and try to make sure that we have compliance and all that stuff. But it is a losing battle because we all know what the state of documentation is in our repositories. And I would argue that 90% of the time it's not good, both from repository documentation, like the README, and both from an architectural perspective. So if I want to ask a bunch of questions across my company, For example, a simple question. Somebody came to me, and this is a real scenario. We want to consolidate all of our monitoring. Across all our repositories, we have to make sure which monitoring tools we use so that we can know how much we're paying them, but also we want to know how much work will it be to consolidate to a single monitoring tool. So if I wanted to ask that question today without RepoSwarm, I have to start searching across GitHub and do a lot of manual work. It could take days or weeks to actually find a good answer. If I have a customer that wants to use our application is HIPAA compliant, and that customer requires a diagram of how we handle data across different parts of the product. How sure are we that that diagram is actually correct, that it's actually up to date? Do we even have such diagrams? In many organizations, they don't actually exist, and if they exist, they're from a bunch of years ago, and they're not actually relevant anymore, and you have to recreate that stuff. It takes a lot of time. If you have a developer that wants to use a new service that was created in the company, and they want to know how to call it, or let's say that you have EventBridge and you want to get a bunch of, to understand the schema of how events flow throughout our system. Where does that get documented? And every company finds its own ways to do that stuff, but a lot of times it's manual. The teams are supposed to do that as part of code review process. It takes a long time, and a lot of times it doesn't actually get done. And now we have a new type of user, an AI coding agent. An AI coding agent where we can ask it to start adding features or fix bugs or change something based on our new requirements. But the agent itself also needs context. For example, I need to add a feature, but I need to see how that feature is being used across our application. Even a simpler example, I need to add a new component, and it needs to use the same component standards across the company in the UI sense. Or I want to make sure that I use the API version 2 instead of version 1 from a service, et cetera, et cetera, et cetera. So I need context of how that stuff is actually being used. And a lot of times, that is missing, and we have to either add custom rules in our AI IDE, or we have to continuously do a lot of work just to teach it how to do it properly. So it sucks. So the two types of liabilities that we have today are the standard README documentation in any repository. Just imagine onboarding into a new repository in your company. I'm sure that some of them are really nice, where you can get a developer from 0 to 100 in 10 minutes, but in many repositories, probably not the case. I would argue, again, 90% of the time, there is no good onboarding story for repositories. And there are no good architecture docs. Sometimes there are, anecdotally in different teams, different locations, but it's all over the place. And even if there were, they are static, they never get updated, and most of them are not really well readable by AI agents. In other words, architecture documentation is usually diagrams or images or PDFs, and maybe sometimes, depending on one of the tools, but it's not really compatible with most AI agents. And repo docs are usually missing a lot of information. So it's kind of a losing battle. And then at some point, when it's losing enough, nobody cares and nobody does anything about it. So at one of our hackathons at the company, we came up with an idea to create a tool called RepoSwarm. And the idea of this tool is to use AI to help us figure out this issue. So I built it for myself, which is usually the best reason to build something. So imagine that you have a tool that goes through all of your repositories, loads them locally in some sort of a local worker, and for each repository documents the current snapshot of that repository in whatever way you want, but in whatever questions you want to ask, and then saves all that information into one small repository called Architecture Hub. And that's what RepoSwarm does. The output of RepoSwarm is one repository. We call it Architecture Hub. You can call it whatever you want. And in that Architecture Hub, the only thing that exists are markdown files and some custom cursor commands. And each markdown file represents a single repository and all of the information you needed about that repository. So I will actually start with the end, and I will show you what does it mean when you have such a repository. which is on GitHub that has full commit history, which is all markdown and is agent ready. And then I'll talk about how it gets generated. Because how it gets generated, the architecture of that is also very interesting. Let's talk about why this is useful. So the atomic level of an architecture hub unit is a repo.arch.md. And in that repo, you have a bunch of sections. You have a high-level overview, you have dependencies, you have security analysis. There's a bunch of stuff here. Each one of them is actually created by a separate prompt and created by a separate call. And all of this stuff gets regenerated on a daily basis. It never gets added or changed. It always gets regenerated and pushed, which basically means that there is no backwards compatibility. If tomorrow you added a completely new component, it will be documented, and there is no need to go back and say, now we've added a new component, because the latest commit of this file will contain this. Here's a full list of all the sections. Now, these sections are not hard-coded. You can create your own sections, and of course, you can control the prompts for each section, and it's all configurable using a simple JSON file and a bunch of markdown files. So these are the things that I care about as a chief architect, but you can do whatever you want. For example, I want to see all the modules in a specific project, all the core entities, dependencies, models. That's the basic stuff. But I also want to know all the database dependencies that I have. What types of databases? What is the database schema that we use? I want to see if we expose any APIs, what is their schema, what is their versioning schema. If we expose any events, either sending or subscribing to events, I want to document that. And I want to see what dependencies on other repositories we have, as far as I can tell. And for each repository, I try to list the dependencies based on literally the requirements file, if I'm using Python or any other dependency file. Deployment, I want to see the CI/CD. How does that work? How do we deploy it? Because we want to standardize on deployment as well. In our company, we have multiple types of deployments for front-end, for back-end, etc., but it's not standardized. We want to standardize it. So how can we standardize before we even know what is the full picture? But just going around and asking 12 different teams and documenting that process takes a long time, so we can get 80% of the way there with this. Authentication. Are we using authentication? What are the big top 10 authentication issues that we have? If we use what authentication library we use, what service, what authorization library do we use? How do we even have authorization? Maybe different teams have different authorization models. Maybe they should all be using the same central model, but they're not. Data mapping. We want to see how the data flows, where the data gets saved, what are the schemas. We have research teams and we have BI teams that use the data. We want to document that stuff. We have security checks. So security check, imagine that you have a security expert and we ask it every time, give me the top 10 items on this repository that if you had to fix tomorrow, fix them, help me plan for that and document them by like top priorities. And it might change. We have monitoring tools, because I want to see what monitoring tools we use. Our company and our production is also using ML services and LLMs. So we document all of the dependencies on all LLMs, how we approach them. We're using Gemini, Claude, we're using a centralized LLM endpoint. Whatever it is, we document it. Feature flags, what types of feature flags do we use? We also do prompt security checks, which is a later addition. Prompt security check is basically to prevent prompt hijacking or prompt injection. Since a lot of our code now uses LLMs, we want to start looking for that stuff. Data layers, basically a deeper level, depending if it's a type of backend or not. And events and messaging, some of these things are deeper level and some of them are higher level. So imagine that all that stuff gets saved in one big markdown file. One big markdown file is processable by any AI agents today mostly, but I'll show you how we use it in a second. And now that stuff has a full history. So every day, if there's a new commit to that repository, I regenerate that entire thing. So on a daily basis, I have a full up-to-date view of a specific repo. But remember that all these repos are now next to each other. So now I have a repository of all of my repositories. So now I can ask questions and use that as one big corpus for my entire thing. That's the really important part here. The difference between this and standard documentation is that it gets recreated, it is never stale, and it is fully readable by AI. So what do we do with this? First level is you can literally open it up in a tool like Cursor, open the architecture hub repository, and start asking questions. So imagine I'm an architect and I want to ask, give me all the monitoring tools that we have today. I open this and within probably 2 to 3 minutes, I have an answer that I trust about 90%. Why 90? Because it's still an LLM. It is not fully consistent, and we need to check it multiple times. And I'll show you what it looks like. Okay, so this is an example of what the repository looks like. This is the sample results hub on the left. I'll show you what it looks like in a second. So our results hub has a list of files, and each file is an example of a report. So let's look at, let's say, I don't know, React router, because I gave it for the sample just a bunch of public repositories. So this is the markdown file, right? You can see it here. I can just use preview here just to make it a bit more readable. You can see repository name, project purpose, major dependencies from package.json, directory structure, well, pretty simple stuff. And as the list goes on, you can see that there's a bunch of stuff to scroll here, which is fine. We don't have to worry about the length of this, because when we use a tool like Cursor or Windsurf or any of the IDEs, all this was generated, right? We don't have to put all of this stuff in our context. The tool itself has agentic capabilities, and it can use CLI tools to search and query things. And it has internal indexing, so basically what it will do is basically RAG. If you don't know what RAG is augmented search, retrieval-augmented generation, which basically indexes all of the content of these files, and helps us find good answers. We don't just ask. I could technically go here and say, choose. How many here have used Cursor before? Okay, cool. If you have never used Cursor, let me give you just a quick example of what it looks like. I'm a big fan of it. I wish they'd pay me to pay that stuff, but no. I usually don't use the Cursor default models for this type of work, but the Opus 4.5 model is pretty good at answering these questions. And I can start asking a simple question, like give me the different languages that exists. And what's going to happen is that it's going to generate a report under the reports folder, which I can also commit. If I just ask a question, what happened at the beginning is that we just opened this and we started experimenting. And we said, okay, give me these answers. And we saw that the answers were very inconsistent. And we always had to repeat the same prompts. For example, double check yourself. Use CLI tools to do matching, so to save a lot of time and tokens. When you generate, also generate diagrams if it makes sense. Double check at the end to verify that there are no false positives, et cetera, et cetera, et cetera. And this is the structure of the report. So you always have to use, if you want a good report, you have to use a good prompt. So in Cursor, you can actually turn prompts into commands. And I'll show you what the command looks like. You have a .cursor folder. Under it, you have commands and rules. And these are a bunch of commands. So command is just a markdown file that looks like this. And this is the prompt that we use to generate a report, right? Read all ArchMD files, but exclude the prompts, diagrams, and report folder, because I don't want to have false positives from previous reports. And look at facts. Actually, I'll turn this into preview, so it will be easier to view. Okay, read all the RTMD files, apply all the cursor rules. For example, how to draw good diagrams, use facts only, no hallucinations. It's funny that you have to write that. Multiple search passes might be needed. Do planning first, write it to a folder called memory. Do research, execute searches based on CLI tools. This is what the report should look like, etc. And there's a quality checklist at the end and different tools that you can use. Right? So this entire thing is one big prompt. But now I can open my chat window and I can say /report and start asking a question. For example, what monitoring tools are used in my repos? Okay. Now, as I execute this, and we're going to let this execute in the background, it's going to plan its next moves. It's going to look at the prompt and use all that as information. It's going to start the planning process. It's going to make a new directory with reports in memory. And generate a report plan and start working. Now it's literally starting to look for different things using RG and a bunch of other CLI tools, looking for different types of monitoring. I don't think it will find a lot of good things here. Honestly, I've never tried this prompt here just for this session. But it will be interesting because some of the projects here are Express, Jest, and a bunch of others related to a lot of interesting stuff like Rollup. I don't know. We'll find what happens. Is that mine? No. Sorry, it was early breakfast. Never mind, my jokes never land. Let's see. So now it's making the directory, it's creating a report, and in this report, I can see, I create a report for by language. You'll see what it looks like. But this is the README file that it's generating. We'll let it generate for a second. And it's also generating a nice diagram. But you can see that based on the model, we're going to actually get different results. In fact, if you run the same prompt again, you're going to get different results because models are not specifically consistent. They're not deterministic. We have to remember that. But for our purposes, it's good enough because a lot of these questions we have to ask, we will also personally not be deterministic. We will also personally find some partial information. So this gets us 80 or 90% of the way to where we want to go, and then we can finish the other 10%. What I usually do with these reports after it finishes is I send them to some of our tech leads, and I say, look at this report, tell me if we missed something really, really important here, or there's a complete bullshit here. And at the beginning, there was a lot of that bullshit, and slowly we got to better and better prompts. So the prompt that you see was written the hard way. Okay, so I'm going to open the preview here. I guess we're going to try to open the preview again. Okay, so every report also shows what prompted it, which agent was being used for it, and now it shows me like an overview. Okay, these have meaningful, this is the summary. Okay, this is using OpenTelemetry, Pinot, custom health checks with Temporal. This is my project. Morgan, I've never seen Morgan. Dev only, okay, React Router, etc. And a bunch of them don't. Even a nice architecture diagram, which ones used what. Let's see. Okay. It's pretty interesting. And you can see detailed diagrams based on the report. Now I can commit this report into Git as well, just so I can then share it with people, or we can rerun this report multiple times, maybe on a quarterly basis, just to see how we're doing. But the point is that generating this report that we literally did while I was talking to everybody here, and here we have, about 20 repositories, nothing more than that. It would not take, it would probably take maybe just double the amount of time on 400 repositories. Because it's not that the report itself might be a bit longer, so that's why it would take longer to generate. So imagine 5 minutes for this report, and it gets you most of the way there. And the worst case scenario, you change your prompt to say, no, what I meant is don't ignore this, but do this. But the report command does 90% of the work, And then we just give it extra context of what we're looking for. And the better model you choose, for example, you can try the Codex or Thinking or Grok. If you use the Thinking model, you might get better results, but it's going to be much more expensive, will take longer. I find with the Composer one, it's actually pretty good, but Sonnet 4.5, Opus 4.5 are really, really good for that stuff. Codex 5 is really good, but very slow. Another example of a report. Let's see. Oh, repos by language. I just did that today, just to see what it would look like. Okay, generated today. Executive summary. Okay, these are the repositories. And there's like, oh, there's a nice distribution here, which is pretty cool. So these are the repositories in this architecture hub, right? So this is the sample architecture hub. This is our real architecture hub, like from work. You can see there's a lot of reports, API gateways. We have projects in C# and Ruby and Python. And of course, TypeScript and JavaScript and HIPAA vendor compliance. And these are just the ones that I committed. There's a bunch of stuff that we haven't even committed, right? Things for MQTT, et cetera, et cetera. So you can see that this is the list of all the different repositories that we care about. We take great care in actually only indexing repositories that have had commits in the past 12 months. Otherwise, it's not really interesting for us unless we specifically look for all the repositories. And you can see that this is an example of a more advanced example of a report. So let me explain what I'm going to show here in a second. Because you can do a lot of stuff. Once you have this output, you can do a lot of stuff with it. By the way, how much time do we have left? 15 minutes? We started at 50, right? Okay. Right, we have 15 minutes left, just to make sure. Am I crazy? Just say yes or no. Yeah. You'll tell me about like 5 minutes before the end? Cool. Just raise your hand when it happens. Okay, so you can onboard new developers, you can do architecture reviews, you can do compliance security, blah, blah, blah. Dependency analysis, really, really interesting. And AI agent context. Now, here's an example of a real-world scenario that happens in many companies. You have a service and you want to deprecate it. Now you have to go and find all the places that use that service across your company and make sure that you create a plan and notify all the teams and all that stuff, and you have to give them a different mechanism. So you have to make sure that you do that stuff. By the way, this is Notebook LM. But, and you have to do all that stuff manually. This will take you, again, 80 or 90% of the way there, and save you days, if not weeks of work, just to make sure that you don't miss a lot of important information. So I used it when we had to update Python versions across all of our company and across our Lambda functions when they got outdated. So imagine we have probably over, let's say, 100 Lambda functions across different repositories in our current product, right? And you have to make sure they're all updated and they're in different repositories. HIPAA compliance docs. We have to consolidate API gateways. Imagine you want to move to something like Kong or something else, but you have a bunch of other API gateways. Just finding out the current state of affairs is very, very, very frustrating. Okay, so this is what monitoring service analysis looks like as a sample. It does remove a lot of manual work, but I'll show you another cool thing that I came across just in the past few weeks, because we've been running this at our company probably for the past 6, maybe more months. So I want you to think about the fact that every day, if there are new commits, each repository gets its own version of the architecture document, right? And then the next day there are new commits, so the architecture hub gets regenerated. I feel like I'm going to make the things go crazy, but fine. So now you have not just like this architecture snapshot, you have architecture history. Architecture history is very interesting because now you can ask really, really cool questions across multiple repositories. For example, you can say, give me an architecture decision record. If anyone hasn't worked with ADRs, it's a common way for us to document important decisions in our product, in our repository. But let's say that you go into a project and that doesn't exist, and you want to retroactively generate something so that you know what the hell is going on. You came into a new project, or you want to document how we got to where we are. You ever came to a project and say, how the hell did it come to this sad state of affairs, or amazing state of affairs? It doesn't matter. But we got here, there was always a good reason how we got here. It's always evolutionary, it's always related to a lot of different things. We don't know why, but we do want to know what happened. So it's like when you cut down a tree and you see the rings in the tree and you want to see what happened. If you look at rocks and you see the different layers in the rocks, it's the same thing. So you can look at the history of a single ArchMD file if you document it over multiple months, and you start doing git diffs across the different architecture document, and you start to see what patterns emerge. Maybe I want to see how dependencies grow or get reduced if we're doing a migration over the next year. Maybe I want to see what innovation experiments our teams are doing across different repositories. Different patterns. We want everyone to use a specific type of pattern. Let's say send events instead of using direct API calls, or the other way around. Or tech adoption and deprecation. Let's say we want to make sure nobody uses Cognito anymore. We want to make sure everybody uses Kong tomorrow. So I want to see that over time. So an ADR record, this is an example of the prompt that generates an ADR record. Now, how did I create this prompt? I did not. I looked at all of the different, the report and and I opened the Architecture Hub, and I asked, I think it was probably Codex 5, and I said, okay, now we have this. Give me examples of really cool creative reports that I haven't thought about, that I can create from this information. And it came up with, oh, you can create an ADR record from this and a bunch of other things. And I started using it, and it's pretty cool. So I generated a lot of these prompts with AI and started experimenting with them. So in this case, the prompt is saying, generate an architectural decision record of timeline, where you go through and you do git history sampling, and you do an analysis and identify architectural decisions, different components that didn't appear in the history, but appear now. It's an example of something that happened, right? So this is an example of what it ends up looking like. This is from one of our real projects, decision to move to serverless. Decision to implement a temporal workflow, which I will talk about in my talk tomorrow. Decision to implement the primary Postgres using multi-LLM integration, another decision, and creating a trackable system, and there's a bunch of these things. Now, these things were not documented, right? You just go into a repository and you see a snapshot. But it's really interesting to see what is new, what is not new. The other way to see it is just to look at the Git history, which most of us do not really do. But this is a really good way to document that stuff. So this is an example of that exact decision record. So you can see here, and you can look at what created it, what files were changed, what dependencies were created, etc. I'm not going to share too much of that because company. Okay. Tech adoption and deprecation. Again, this is a different prompt. Each one of them is basically a command. So report.tech adoption, report.something. And you can create your own custom commands as much as you want. And it's really cool what you have when you have this corpus. And of course, you can do a lot of more interesting things. You can do RAG on top of this. You can start using it in other AI agent activities. So I'll do a quick overview of how this works under the covers, because just building it was a really nice experience. So the way RepoSwarm engine works, the thing that generates that architecture hub repository is its own project. It lives in a temporal orchestration workflow engine, which I will not explain too much about. But basically just imagine a VM or a worker that starts this entire thing and is very durable and can continue with errors, etc., and retries and timeouts. And I'll talk more about that tomorrow, like how we ended up building that stuff. But at the basic level, it has access to our GitHub account with a special GitHub token. And it does a discovery. And the discovery it does is based on repos.json. I can give it a bunch of different repos that I really care about, but it will also automatically discover new repositories with new commits. So I don't have to keep updating the repos.json. I can just give it the initial ones. And I can also, of course, give it repos that I don't control, like public repos that I have access to. And then we filter them to repos that are older than 1 year. And I also might filter with the special skip repos because some repositories I don't want to document. Maybe they're just hackathon repositories, they're just adding some extra noise, etc. So you can skip repositories. It generates this automatically with no commits in past 1 year, and you can add to this repos.json. So the entire engine is controlled with JSON. And then the next thing that happens is after we have a list of all these repositories, we do a fan-out move. And the fan-out move is basically creating a new workflow or a new process, or literally starting a new orchestration workflow. And that orchestration workflow will get the latest version of the Git repository and then use Claude Code SDK. They recently renamed to Agent SDK, but it's the same thing. And using Claude Code SDK, it will interrogate the repository. So remember how I wrote a text here and I prompted it? I literally use Claude Code SDK to prompt in a specific folder, and then it uses Claude and Anthropic Agent SDK under the covers to interrogate the same thing. So when I ask it, give me all of the different components, it literally does a lot of the things that you saw me do before inside Cursor, and it does it completely in memory. But it does use CLI tools where it needs to, and it's the same engine that runs under Claude Code. It's very, very powerful, and I highly recommend trying it. This stuff has been running for us at least 6 months. Before all of the other agentic framework already existed, like Crew AI and a bunch of stuff, this stuff just works. It's really, really nice when you want to interrogate code. Nothing better, as far as I'm concerned. Because for all the other agents, you have to get all the code, generate context, send it to the prompt, and Claude Code does all that for you. It will do everything that you need to do. So we don't really have to do a lot of work here. So the fan-out happens for all the repositories. It will check if there's actually commits. It will clone the repo. It will analyze the structure, execute the prompts, store the results, and do cleanup. The prompts are basically the core of this product. So there's the prompts, and then there's the product that runs the prompts across different repositories. So it's not that complicated, and the prompts are, that's the thing that makes or breaks the entire thing. Everything else is just glue to connect all the results and all that stuff. So we have base prompts, and we have specialized prompts. So base prompts, all repositories get. Specialized prompts are for different types. For example, there are some prompts I don't want to ask if I'm not in a mobile-specific repository. And there are some prompts I don't want to ask if I'm in a backend instead of a front-end repository. There's just extra information, right? So the base prompts apply to everything. Let's say security check. But backend or front-end prompts add extra prompts to it. So this entire thing will execute the prompts one by one for each repository. There is a thought about parallelizing that stuff, but the cool stuff about this is that you can take the result of one prompt and then inject it into the next one so you can give more context. So for many of these prompts, we have a high-level overview that we start with, and then we inject the high-level overview to every other question. With 5 minutes? Cool. So we use them one by one because we sometimes use the result from a higher-level prompt into a lower-level prompt, and it gets the job done much better that way. So the prompts JSON basically lists all the stuff inside the shared repository. Actually, let me show you at the basically what this repository looks like. You can see this font, right? Let me make sure. Is this better? Sorry. Okay. At the end of the day, the prompts directory here, that's the most important part. The base prompts, that's where the core of this lives, and it just references the prompts here. So if I just look at, let's say, dependencies, or let's say events, I don't know, authentication. This is what the authentication prompts exist here, and it has versions. Why are versions important? Because we can have versions of prompts, and if I change the version of a prompt, in the next run, even if there are no new commits, the workflow will run again just with that prompt. So there's a lot of optimization going on to save tokens. So we only run prompts if they have changed or if the code has changed. If the code has changed, we run all the prompts. If the prompt has changed, we just run that specific prompt. And then everything else we use from a cache. And it can use DynamoDB for the caching mechanism or local file system. So there's prompt inheritance and tagging based on the type of the file. That's the base prompt and context chaining. So let's say for a security check, we actually we have two contexts. So we literally, in the prompt, we can say, I want you to give me the prompt from step HL overview and ML services when you run this third prompt, like prompt security check. That way, I don't have to reinvestigate, or I make sure that I get much more information out of this. This is deployment prompt, etc. Token optimizations, we only investigate a repo if new commits exist and only run on a specific prompt. To investigate a repo takes between 10 and 15 minutes, usually. For small repos, it's of course much shorter. And it takes between 30 cents and $1 to investigate a repo, depending on which model you use. And one of the plans is to add more logging there. Okay, so the road ahead. This is still, right now, the output is just a repo that you can grab, and all of our developers can open that repository locally with the workspace and then just add features, and then the agent uses that as context automatically. But we can open it and just ask questions. We want to add Slackbot integration when there's really important stuff happening, like the security check found something really, really important. We want to do automated RAG. So basically take this entire thing, index it, and then have a Slackbot that you can query and start asking questions without opening even cursor. Cross-repo reasoning, so basically we want the investigation to even open other repositories while it investigates a single repository to verify dependencies across different things, and open it as an MCP so that other agents can use it in the future. If you want to contribute to this, fork this, etc., it's completely open source. You can go to this URL to look at the blog post, and in that blog post there is a link to that repository. Thank you very much, everybody. May the force be with you. May your designs be amazing. Thank you.